Welcome to Brain Vision.
This question says we have two long parallel wires and they're a distance d apart. They each have a current I. One wire is at x equals 0. The other one is at x equals d. That's why they're a distance d apart, as in figure 38 if you want to look at a reference. We're asked to determine the vector b, or the vector for the magnetic field along the x-axis between the wires as a function of x. And it actually says here as a function of x1. So we can now consider some value x1 less than d, right? So it says to find it as a function of x1, where x1 is less than the distance d. Okay. And it's somewhere, so then it's somewhere between 0 and d. The magnetic field, due to the left wire, would be B sub L, and the magnetic field due to the right wire we're going to call B sub R. So the total magnetic field vector is going to be equal to B sub L plus B sub R. So if we plug in the magnetic field as a function of current and distance, this is mu naught, which is a magnetic permeability of free space, times I divided by 2 times pi times the distance x sub 1, and this is acting in the j hat direction. So that's B sub L plus B sub R. B sub R is going to be u naught times I divided by 2 times pi, and then the distance here was going to be the distance d minus x sub 1. And this is also in the j hat direction. So since they're both in the j hat direction, we can add them together and simplify. They both have a common constant of mu naught over 2 pi, including as well as the current I. So we can write this as mu naught I over 2 pi. And we're left with 1 over x1 minus 1 over d minus x1. And this is all in the j hat direction since it's a vector. So we can go ahead and box that in as our solution to the question.